Hello, everybody, and welcome. I am Professor Richard Lambeck. I am the chair of the Construction Management Graduate Program at NYU SPS Schack Institute of Real Estate. Today, we have a very interesting seminar to present to you. The presentation is going to be done on a BIM, Building Information Modeling, presentation of NYU's project, the Mercer project in Manhattan. The contractor is Turner Construction, and Turner was involved with using BIM for this particular project as well. The person who heads up the BIM team is Ayse Polat with her colleagues, and Ayse is also an adjunct at NYU SPS Schack Institute of Real Estate, where she teaches a course in BIM to our graduate students. So this is going to be helpful for everybody learning about BIM and how we use it and how specifically it was used for the Mercer project. So now I'm going to turn it over to Ayse. Thank you very much, the whole Turner team. Go ahead, Ayse.
Thank you, Professor Lambeck. First of all, thank you very much for inviting us for this great presentation opportunity, because first of all, I am very honored to be an adjunct instructor at NYU and be part of the NYU community, as well as being involved with this project for NYU is a double win, I would say. Thank you so much. Welcome, everyone. Hope you will enjoy this presentation because we have a lot of valuable information about BIM and the project itself. So let's start with a basic introduction for our company first. Turner Construction is a very old company founded in 1902. We have over 46 offices nationwide and internationally other offices, and we have $14 billion construction volume. But of course, I would like to mention about our virtual design and construction BIM department as a New York VDC. We are a team of 32 people. We have 2 different entities, field operations and pre-construction and sales. Currently, we have over 18 projects on operations and 13 projects in pre-construction. Of course, we are not a stranger to NYU. Again, we have so many finished projects with NYU. NYU is one of our valuable clients. These are some of the samples from the projects that we currently completed, and the 181 Mercer is currently ongoing. So let's introduce ourselves first before we start the NYU 181 Mercer presentation. So my name is Ayse Polat. I'm the regional BDC manager for New York Business Unit at Turner. Also, I'm an adjunct instructor at NYU Schack SPS and teaching BIM classes. Actually, this presentation that you are going to see, this project was our last semester, our final assignment for our students, and they actually worked on these models. So I'm proud to say that NYU also, as a student, graduate students helped the BIM team for certain things in the project. Been with Turner around 11 years, and I'm a licensed architect in the state of New York, coming from an architectural background. Saying that, I will turn over to Sal. Sal, you are muted.
Sorry about that, guys. I was muted. My name's Sal Perrone. I've been with Turner around 9 years. I think next month will be 9 years. Prior to Turner, I was involved in manufacturing, worked with a group of people that designed and manufactured equipment for the nanotechnologies, also chemical vapor deposition industry. And I transitioned over to construction from that 9 years ago. My role at Turner is a VDC project manager. A couple of the things I take care of are project setup, staffing for virtual design and construction projects. Also give just general support to our VDC engineers. All right, I'll turn it to Bill.
Hi, everyone. My name is Bill. My educational background is in civil engineering. I spent a little time in the oil and gas industry. And then after that, I've been working for Turner for about 4 years doing mostly VDC work, mixed with a little bit of everything.
Yep. Thanks, Bill. Also, we would like to mention John Angelescu and Yusuf Ali, our VDC engineers. Actually, Yusuf is also an NYU graduate. So we wanted to mention that he actively worked on this project as well. So let's talk about NYU Mercer. It's a very unique project because scale-wise and the location-wise is in the heart of NYU. Project consists of a phased demolition of existing Coles Athletic Building and the construction of a new mixed-use building, which will consist of, some athletic programs, performing arts, theater, classrooms, and student and faculty housing. So currently in 2020, work performed was very busy. So structural steel, precast planks, and cast in place concrete, a lot of completion of spray on fireproofing, curtain wall installation, delivery of major MEP equipment. It was really a very busy year for the project 2020. So some metrics from the project. So as I mentioned it before, it's a large scale project. It's a mixed use academic, 750,000 square feet, 23 floors. Area per floor varies according to podium and towers, and it's a GMP contract type, guaranteed maximum price. So I will turn over to Bill to mention about the project team because he is more familiar to the group.
Yeah, so on the slide here is our large team of design professionals that NYU hired to design this building. The architect of record would be Davis Brody Bonds. So they hold all the contracts and hired all of these consultants on the screen right now, with the exception of obviously Turner. But it was really exciting to work with all these different companies and learn all their expertise in their specific fields. And we spent a good amount of time with a select few of them during the BIM process and doing coordination of this building. A lot of time with the architects, Davis Brody, Kieran Timberlake, and the MEP engineers over at BR+A. So they were integral to this whole process. And I like to think that we showed them the Turner way to coordinate a building. So hopefully they take some of the procedures and skills to their next project.
Yep. Of course, we would like to thank all the team members here, from designers and the construction side, to really work hard to accomplish the milestones in the project. So, Sal, you want to talk about the Turner project?
A little bit about our staff. As we said, it's a very large project. Our site has 66 people from Turner working there daily. That would consist of, well, we'll start with our VDC staff. We have 4. We have 1 lead VDC engineer, 2 VDC engineers, which are full-time on site, and then VDC project manager, which is myself, and I'm part-time on that project. Some of our other staff include our safety team, our superintendents. We have our management team is on site. And in addition to that, we have some back office support from our main office that, some of that team would be like our procurement department, our accountants, cost. Our VDC pre-construction team also has helped out on this project. And we also have our senior management in our main office. You can go to the next slide. All right, so a little bit about a couple of facts about our field staff. So currently, the month of March, we had approximately between 450 and 600 workers per day coming into the project. So that should tell you a little bit about the scale of this job. And the cumulative hours of around 43,000 man hours put in the month of March. From, I think it was 2016 demo till now, we had logged about 1.5 million man hours through last month. And believe it or not, our peak construction manpower, which will be coming up, we're looking to see around 700 workers per day coming into the site. I'll turn it over to Bill. He'll give you a little little information on the building, where some different
Yeah.
work streams are happening.
So if you haven't seen these images on NYU's website, they give you a good sense of what's going to be inside. That won't be really apparent from the street when it's built. But 181 Mercer's got a little bit of everything. It's got housing for both faculty and students. It's got academic spaces, both for regular classrooms and performance studios, as well as athletics in the basement. There's going to be performance theaters, one of them holding up to 300 people. And it's got mechanical spaces throughout each of the towers and in the basement as well. So it's really complex building. It's a lot going on, and it changes every floor. So it's a really exciting place to build, and I can't imagine what it's going to be like to enter once it's finished.
So let's talk about the BIM part of the project. Of course, project is very large scale, a lot of mixed uses. In any building information modeling, BIM users can be performing construction site, and these technologies are, year by year is increasing and advancing. So you see some of the BIM uses that we have on the screen that we currently on typical job sites, some or most of them are being used. But for this project, we actually did a virtual trade coordination, logistics and safety planning, and 5D, 6D, and laser scanning, model-based layout, virtual production tracking, 3D printing, and the lean and BIM integration. So I would say that for the following slides, you will see some samples of them. And these BIM users are actively used in the project and being used currently. And we will start first with the coordination, because coordination is probably one of the most important BIM activity on the construction sites. And Bill, since he has been involved with the project since the beginning, he will explain us a lot of coordination setup. But first, Sal is going to mention us how the coordination being set up as a contractual wise and the BIM execution plan wise. Sal?
Okay, yeah, I'll go through a few of the things that we did prior to coordination and setting up for the project. There's many facets to setting up BIM on a project. So initially, to start off, we usually start off with a BIM implementation plan, which we did on this project, and we meet with the project team. We discuss the project, we learn about it, and we decide as a team what uses we want to implement on the job. From there, we'll start getting into setting up contracts with subcontractors. It's also, you can also refer them as kind of like requirements for the subcontractors. We want to ensure that the subcontractors give us the deliverables that are required for the project. It also was a way to hold subcontractors accountable. This is put into their contracts, and it is something that's owed to us. So we're very diligent on that portion. But the other important thing is when we start setting up schedule. This is always done, and we work closely with our senior MEP manager on the team to make sure our coordination schedule and the project schedule coincide. That's extremely important process. And the BIM coordination schedule can change at times through coordination. As we progress, we may find a better route to go. But generally it stays as set. We also create what's called a BIM execution plan, which we did on this job. It was pretty involved, pretty detailed, being such a large project. This is pretty good. You can pretty much look at this as like a guide for our subcontractors. It defines several things. I'll go through a couple of them. It'll make sure our subcontractors define the naming of their files. It'll go into colors of their models. It'll give them some file exchange standards, software requirements, and it'll just outline the general coordination process, just to name a few things that are in the BIM execution plan. So on this project, doing the schedule, we realized we needed several coordination teams to get it done. So we did set up 3 teams on this project. So we had the 3 VDC engineers running a team each of subcontractors, and because of the complexity of the job, we required a subcontractor to provide a sketcher and back office staff to keep up with the schedule on this job. So it's a very large BIM group on the project.
Yeah, thank you, Sal. Schedule is very critical to BIM coordination. We basically need to be ready to build the building, you know, when out the field is ready for us to install some MEPs. So the video you're seeing on the screen is a walkthrough of a live coordination model after we finished coordinating it. So this is kind of the final product of BIM coordination, where we kind of put together the building in 3D before we actually build it, so that it's actually buildable in a timely manner when we get to the field. So one of my favorite things about BIM and utilizing it as a tool is it really makes me feel like a superhero, because it kind of gives me X-ray vision. I can see through walls, I can change through colors, I can walk through walls and really get a feel for how the building is going to be built when it's done, but also how it gets put together. So I'm going to let this video, it's going to loop. We'll start it over again, but taking you through the specifics of what you're seeing is we're walking, this is on the south side of the building. There's a terrace for the faculty housing. And it's really cool that you get to see, pop your head above the ceiling of what you're not going to see when the space is finished. So it takes us a lot of time to really make sure everything's fitting and we can build it without hitting each other once we're out in the field. So this is more of a finished space, but then we walk into a back of house area where our mechanical room, one of our biggest mechanical rooms on the job is. So we're actually building this out in the field right now, and we really used BIM to put this together in 3D before we build it. And you can see it's a very complex space with a lot of layers. It took a lot of time to figure out where everything was going. And one of the most important parts of this mechanical room is this prefabricated mechanical skid. So everything in red you're seeing was shipped to the site in just 3 pieces. So 3 large pieces that were picked by the crane and set onto this mezzanine here. So it was a highlight of our MEP systems, that prefabricated skid. So this next slide is kind of the other side of the coordination coin, whereas the first video was kind of a typical MEP coordination mechanical room. The video that's looping now is an example of one of the many kind of very unique and challenging coordination spaces of NYU Mercer. This being the biggest theater, the proscenium theater on the job. So what's important to highlight about this space is we didn't have your standard, or we did not just have our standard MEP coordination, but we had a lot of high-end finishes from the millwork side, from the architectural side, from the theater rigging side to the AV side. So there's a lot more than just your standard MEP coordination in these spaces. And so the next few slides, I'm just going to highlight those performance spaces in NYU Mercer, and I'm going to cherry pick the proscenium theater because it was my first time doing a theater. So I haven't seen many theaters in my life, so I kind of had to refer to some images on what it might look like, which is the image on the left to our coordination model on the right. So when you're coordinating a space, if you're not familiar with it, you just have to reach out to all your resources available to make sure that you're coordinating it correctly, so you understand what it's actually going to look like and how it gets built. Here on the left, we have acoustic banners, and I didn't know what these were when we started coordinating, but I asked my team and found some images, and I used the image on the left to kind of understand our coordination model on the right. And what you see in pink is basically what's being fabricated and what's being installed in one of our theaters. And it was challenging because we had to rely on our subcontractor to really explain and provide a detailed model of not only just what the housing looked like, but all the supports and what it was actually going to look like when it was deployed, to make sure we were clear of everything that was around these acoustic banners. Next slide, please. So an interesting part of the proscenium theater was the overall seating coordination, where we have in the image on the left is a detailed model from our seating lift manufacturer, a company out of Canada named Gala. And the image on the left is the product of what the image on the right is, and the right is the contract documents, where that was the overall design, what it was supposed to look like. And then we got the model on the left from our subcontractor, and he was able to put it in the model, and it's a very detailed model and really helped me understand, how things moved around and make sure we were allocating enough space for this lift to go in. And then one of the more challenging parts of the big theater was the overall seating rake, where we have the majority of the seats in the big theater. It's a sealed concrete plenum, mechanical plenum. So underneath we have a large system of ductwork where we're pumping air into basically an open void. And under most seats, there's a cylindrical air diffuser that is going to slowly diffuse the conditioned air from below to under your seat without your noticing it. And one thing we used BIM to coordinate this area heavily on was pulling all the different models together to really see the whole picture, from the seating location, the diffuser locations, understanding what was going on from a structural standpoint with the support steel below, to the masonry walls that were forming our concrete plenum on the sides. So the coordination model was really a tool for us to see everything in one spot and make any adjustments that were required due to any conflicts with steel or how we were fitting in the electrical devices for the seating lights. So the coordination model was really the best place for us to kind of bring everything together and really look at it as an entire picture. Next slide, please. So this image on the screen is kind of a before and after. The image on the left is a snapshot of an above ceiling plenum we have on the 6th floor. And the models on the left are what the design team provided from BR+A and Davis Brody. So these images are what kind of produce the contract documents and what look like the drawings that we build off and submit shop drawings to. Now the image on the right is what it looked like after we coordinated the floor. So aside from the colors being different, you can kind of notice there's a few more systems. The systems that are the same look a little different. Some grew in size, some shrink in size. Things move around, things get rerouted, but the image on the right is kind of the final product of how we're actually going to build the systems above the ceiling on this floor. So you can see it's quite a stark difference between the two. Next slide. The next few images are just quick snapshots of just how complicated some of our spaces are in 181 Mercer. There's a lot of layers, especially for the first 6 floors of the building. They're relatively tall with high ceiling plenums, especially on the 5th floor, where we just have a ton of layers of MEPs overhead. And what I wanted to kind of highlight in this image here is we don't only draw and coordinate the physical system where it's ductwork, piping, or conduit. We actually maintain access zones, which you can see in this picture here, the yellow boxes and the red boxes. We need to simulate and account for future maintenance or any type of future access that a human being is going to have to physically get up above a ceiling and either change out filters or perform maintenance on any type of equipment. So we actually draw those zones, simulating access in our coordination model, and provide space for those activities to happen. So throughout the coordination process, we need to document and kind of track through how we're making changes to a floor. And what we're showing now is a kind of a summary report of all the issues we encounter on a floor. And I would track these issues and kind of bring it all together in one singular place and share with the project team to kind of look at where we're having problems, where we need to focus our attention to kind of meet our schedule and maintain a kind of momentum through floors so that we're ready for the building when it's ready to be built out there. So I had to pull together a lot of information just to kind of share at a high level, where we might need to reallocate some resources or spend more time focusing on a specific issue on a coordination floor. So best practices, this is kind of a high conceptual level kind of thing for coordination without going into the details of what exactly we did at NYU Mercer. What it basically kind of comes down to is collaboration and keeping communication lines open. And that's not limited to just talking to your subcontractors and then taking that information and talking to the owner or your design consultants. It's kind of bringing everyone together in the same room so no one's working in a vacuum. So what we found to be really successful at NYU Mercer was weekly meetings with not only just one-on-one subcontractors, but bringing everyone in the same room to kind of understand both the design intent from the design professional side, but also any constraints, whether they be constructability or manufacturing from the subcontracting side. So getting everyone in the same room to kind of look at the issues at hand and understand where everyone is coming from to move past certain issues was super important. One other best practice and really thing I like to do in coordination is always think about the end users. And what was unique for me at NYU Mercer is that we were coordinating and building a lot of spaces that I didn't really have much experience with before this job, those being performance spaces. So we were always talking with NYU about how the space was going to operate and function from an end user perspective. So all the theater groups, all the academics, we were talking with them to make sure that we were giving them a product that they were expecting that they were going to be able to use successfully. On the other side, mechanical rooms, I've done a few in my past, and another thing we like to do at NYU Mercer is, as we're coordinating our mechanical spaces, we really like to bring facilities management in, walk them through the model, similar to the video I showed earlier, to kind of show them their mechanical room and help them understand, what they were getting and any changes they might want to make, before we actually build it, kind of walk them through how they would maintain a certain piece of equipment or get to a certain point. It was really, really helpful to have them in the room with us.
Okay. Thanks, Bill. This was a lot of insight from coordination.
Yeah, ran through that pretty quick.
Yeah, which is very important for the project. Another important part of BIM processes is when we use BIM tools for site safety plans and logistics. Again, this project is in the heart of Manhattan, and a lot of projects has a lot of logistical site safety related challenges, and as well as this project as well. So we developed the site safety plans in 3D. And also, as you may know, that Department of Building for major projects requires a site safety, official site safety plan submissions for the plan examiners to review the site safety logistics and the related permits. So we did the same process in-house. We generated 3D site safety logistics plans. We shared those 3D models and the drawings and all the permit-related submission requirements to DOB. For the approvals. Those are the samples that you see from the original submission. Of course, this project had unique challenges, the complexity of the project and the location of it, the unique challenges for the logistics, as well as being in the residential area. So we use, for example, high acoustical fencing around the site, make sure that we have 20 feet high sidewalk bridges, because public protection, the public safety is our first priority for every project, as well as the Department of Building. So those were very important aspects of the site logistics. So I always say that the site safety logistics are actually a storytelling. As an architect, as my background, I never knew how important the site safety logistics for construction, because it's a storytelling for how we build the construction, how we build the building, actually. Where the cranes are going to be located, where the hoists are going to be every piece has a certain phase and a timeline that, in order to achieve a successful site safety. But another challenge was, of course, with any other construction and design industry faced with COVID-19 challenges during 2020 and ongoing right now in 2021, of course, the site followed all the CDC and state guidelines. We added additional hand washing and sanitizer stations throughout the project. Modified shanty areas, I believe that was a brilliant idea because we had more open spaces for the workers to get their lunch breaks and the time frame changings. So in that case, like they can have a better environment, protected environment. Also daily temperature checks, COVID-19 testing, social distancing was one of the most important one that we try to ensure. Partition, in the site offices, another precautions that we need to take, partitions between desks, limited conference room accesses, certain directional walkways, and as everybody knows, increased virtual meetings like we live in online right now with the meetings. So those are pretty standard, prevention techniques that we took during the COVID-19 pandemic, and currently we are following the same guidelines and follow the rules and regulations. You want to talk about this, Bill?
Yeah. So backing up to a little bit towards the logistics end of it, we use BIM a lot for logistics planning, not just for coordination of how things are going to look when they're in place, but how do we get them in the building. And I had to create this video back when we were trying to rig one of our prefabricated skids into the basement mechanical room. So that pink box represents one of the 5 pieces of our large prefabricated skid in the subcellar of this building. And we had to bring it in at a time in the building where steel was already being erected. So I had to perform this study pretty quickly to kind of communicate our plan to our rigging contractor, to kind of show them how exactly we were planning on bringing these 5 pieces into the building and how it was going to traverse the building with certain pieces of steel already in place. And we kind of used it to really understand. It's like, oh, we had to leave a certain piece of steel out to be able to fit this in. So we use this tool to kind of just communicate the overall plan without actually having to walk outside the building and kind of, walk through the spaces. It was kind of a bird's eye view of what we wanted to do. So we turned this over to the rigging contractor. They then produced their engineer drawings and all the reports and everything, and then gave it back to us, and it worked out pretty well. Did the video play? It was kind of slow.
Yeah, I think it's, oh, sorry. Let's talk about the tracking maybe. Sorry.
Okay.
Oops.
Yeah, let's back up.
Okay.
So yeah, you can play the next video.
Sure.
So after we coordinate and after we have these models that represent, what's being built, and if we've used them to kind of plan how we get it in place, the next big step in using BIM on a project of this size is seeing how the building is getting built as it's being built. And one of the tools we're using at NYU Mercer is an Autodesk product called Assemble, which essentially takes our coordinated models and it allows us to highlight, for lack of a better term, or assign statuses and data to certain pieces in the model to help us visualize the work that's actually being put in place and how it's being put in place and when it's being put in place. So it's a kind of a step forward from conventional techniques of tracking work in place via highlighted drawings by hand or electronically, or some combination of spreadsheets and other tracking mechanisms in Excel. These new tools allow us to use the coordinated models and visualize the building in 3D space and what pieces are going in at what time. So it's a tool we can use both on the computer and in the field, as you can see in the iPad, and it lets us kind of track, collect data to see how the building is getting put together without actually walking the space. You can see a lot more information in a shorter amount of time. So if you go to the next video, we're using it for a lot of trades on this building, most of our mechanicals. And the other big one is going to be our curtain wall. So we have a curtain wall tracking model in this tool. And what this video is going to show is just kind of gives you an overview of what the tracking model looks like and how the information is getting put in, but also the reporting end of it and how are people digesting and using this information. So all the data that gets put into Assemble is linked to another system that everyone has access to on the project team, and it's a live data refresh that as soon as the model is put into Assemble, we see it on the reporting end. So the project team can look into these dashboards every day and see how work is progressing, to see if there are any problems being flagged by the fields, and see if any decisions kind of need to be made about maybe changing our schedule, our angle of attack, or seeing how many problems we might be having with certain pieces. And it's just a tool to centralize the information and use it to make decisions.
Well, that's actually all we have right now. So I think we have plenty of time for the questions, but just wanted to thank to my group for working diligently on all these BIM processes and making sure that team collaborates enough. And so some of the technologies that we use here that is being used on other construction sites as well, especially with the newest trends that the coordination and anything evolves around the coordination is more advanced now. For example, you have seen some tracking samples. I believe, Bill, correct me if I'm wrong, but I believe there are multiple trades in the tracking process right now, like being most important one was the steel and the curtain wall, right?
Right, we highlighted the curtain wall, and we showed a video of ductwork being tracked, but yeah, all of our major MEP systems and down to our architectural and masonry walls are being tracked as well. So basically anything we have a model for, we're tracking it.
Yep, that helps a lot of, that makes a lot of automation in the process, especially with our engineers and supers. They really enjoy using those technologies. Well, thank you very much.
Ayse,
Go ahead.
Ayse,
Yeah.
this is Richard. Thank you very much. There is several questions. You probably could open it up on the question and answer. Do you see that?
Mm-hmm.
Sure.
On the bottom of the screen, and maybe you just go through the questions that are raised by the so-called participants and maybe just answer their questions. Can you see that?
Yes.
Okay.
So let's start with the first one. So I'm just going to go down the list. Please feel free to add some questions. I'm going to start with first one. How is BIM digital technology being leveraged for a quality assurance measure? So I would say that as an overall, like being overseeing the 18 job sites, definitely our biggest intent is to make sure that whatever is the design intent is being delivered and into a real, more concrete process, which is construction. So and making sure that my first priority in the group and our group as well as a BDC department, that we want to make sure that the design is being executed in the reasonable point that we can coordinate everything and deliver it what the design team's vision is. But I would say that maybe Bill and Sal can add to this a little more.
I think,
Bill? Yes,
well,
Sal?
I'll go first. Yeah, I think if I'm addressing this question correctly, I think one of the ways we assure that things are being installed the way they were coordinated or the way they should have been designed is we have our supers and the foreman for our subcontractors all have access to our live coordination model. So as they build, they can reference those models, which would help. And I think, Bill, if you can add on to that, now that you're out in the field, you may have a little more insight on that. But I think that's one of the important tools, is just to get that live coordinated model out into the field.
Right, yeah, Sal's exactly right. After we coordinate a floor and we're actually building it, each one of our subcontractors has their own set of shop drawings that they're building off of. But it's always good to have the coordinated model with everything in it that's on a floor to reference, to make sure that
Right.
everyone's being installed in the right place that we agreed to, when we coordinated the space. So I'm spending more and more time out in the field now at NYU Mercer, and I'm constantly taking the model with me to kind of just do spot checks to see if people are installing in the right place. I will add, to kind of ensure quality more on the design side. We put together a simple, but I think it was fairly important, a 3D mock-up actually, before we made a plan to do a physical mock-up of one of our ornamental stairs. We wanted to plan what that piece of a stair, mock-up is something we build ahead of time to get approval on what it actually looks like. And what we did for a section of our ornamental stairs was took tiny little pieces of the actual stair from all the different trades that were participating, and we built our mock-up structure in 3D and had a kind of a virtual mock-up before us, so that before we built the actual mock-up in the fields, we kind of had a plan of what the mock-up was going to look like in 3D and make sure it all looked good before we actually built it.
Okay, thank you very much for chiming in. Let's see, what are the other things? So there is a question about sustainability. So we didn't include the presentations, the sustainability measures, but the project is, I believe, targeting LEED Silver. And also we have a assigned team member who is following all the credits and the calculations. Another question was related to how we create our documentation, like animations, BIM execution plans. If we follow certain, yes, we follow, of course, certain guidelines, but Turner has been doing this for years. I would say we are definitely adding year by year a lot of lesson learned, and we follow certain guidelines. As animation techniques, we have a variety of software platforms that we use. Navisworks is one of them. It was a question. Also, we use different software platforms, but of course, we are not here to promote any software. But there are, a lot of options on the market that you guys can try and use it. Bill, there is a question about what changes made in the design during pandemic. Like, is there any design changes, like air handlers, lobby elevators, or anything related to pandemic, or filters or something else? Was there any discussion with the design team for that?
No, not in terms of final design of the building. We did make temporary measures possible during the course of construction to kind of account for what we need to do during the pandemic. But as far as the final building design, I'm not aware of any changes to NYU Mercer. Not yet.
Probably it was too late because like the design was completed years back. Another question is, what is the project management tool software we use to keep everyone in the loop? The construction management software is, I believe, is it Procore?
Yep. So our suite of tools we're using, I can run through them. So Procore is our construction management. We're using BIM 360 Glue, which is kind of an older Autodesk platform to store all of our coordination models and run our coordination clashes to coordinate the models. We're using some parts of BIM 360 just as a testing as it's being rolled out, which is the new Autodesk platform. we're also using, as I mentioned, Assemble. Assemble is also an Autodesk tool that we're uploading our coordinated models into Assemble to track the work in place.
I think the BIM track, right, Bill,
Yeah.
would be the main tool that kept everybody in the loop.
Right. So the image of the report I showed for our coordination issues, that was a report I created with Power BI, which is a Microsoft product, that pulled information from BIM track. And BIM track is a cloud, collaboration tool that tracks BIM issues or coordination issues, and it integrates with Navisworks. So we're able to basically track issues and assign tasks and have conversations about specific coordination issues. And it's all linked in our coordination models. So it's a really kind of great tool to use. It was really helpful in this job.
So another question was, I believe we can all answer this question, but we can talk about it forever. What are some issues, shortcomings of BIM software infrastructure that you would like to see improvement on? Again, we work with a lot of BIM software and platforms, and interoperability is a very well-known common problem among them. And data transfer can be this digital data or the information data, whatever that you want to extract from the project. These are one of the biggest challenges, but for project specific, I will turn to, Sal and Bill, if you had any issues with the BIM software platforms that you needed some improvement.
The only one I could think of, and Bill could probably elaborate on it, was when we went into the pandemic and we started working remotely. We needed a quick way of sharing the design models because they were very large and it was very time consuming to try to pull those from a server onto your local machine. So I think Bill and I had a discussion, and Bill went and set up BIM 360 Revit work sharing, and he had some issues because of the versions of Revit. So maybe Bill, you could explain a little bit more on that. So there were some limitations there. But once he got it going, you can go into it, Bill, and how helpful it was with that remote working.
Yeah, and I think I can answer one of the earlier questions about which model the design team were using and how we were managing it at the same time. So we, as Turner, as a GC, we take the architecture models from the architects, their design models, and we kind of use those as our backgrounds for coordination. And we will, if we have models from our architectural trades, that we will pull those out of our architectural design model and put those in our coordination model. But we are responsible for taking the architectural Revit files from the design team and putting them onto our coordination platform, which was Glue in this case. So during the pandemic, when everyone started working remotely, we went from being used to having a shared network server on the job site to having to remote in to access those large Revit files. So when we got moved to working remotely, we needed a way to more quickly access and open these large files. So as Sal said, I tried to use with the tools we had at our disposal, being BIM 360, I tested it out and we went through some hiccups, but we were able to take our Revit files off our local network drive at the job site and put them on Autodesk servers that are more easily accessed from home. And that saved us hours and hours every week when we were working remotely, opening these models that are sometimes, 1 to 2 gigabytes.
I think that's like the question is like the shortcoming was that the hiccups Bill ran into was just compatibility with certain Revit versions with what work sharing platform what it would take. So it was just a little bit to work out, and we just had to revert back. So I guess the way to look at it is the shortcoming was it wasn't compatible with all versions, and we wish that would have worked, and wish that was something that they could change. That's all. Without having to spend a lot of time and have workarounds with that. So hope that answers your question.
Yep. So another thing is that in this project and many other projects we use laser scanning techniques. Reality capture files are fairly large, and due to current conditions, we mostly work, remotely, and those file storage methods and processes change in our company within our department. But we use a lot of course, cloud-based techniques. We have some local drives that set up to easy access. VPN has been always a challenge. Like, there are a lot of challenges, of course, but I believe the biggest challenge is that different platforms communicating each other has been always a challenge in the project, because we have variety of softwares we use, and as well as project management tools that now tie to BIM. As you see on the tracking, those trackings in some of the projects are tied to SOVs. So these are all, making the process and the data transfer is a little bit challenging. Let me ask another question is, how does BIM digital technology enhance project controls? Yeah, we get more and more closer with the project team and the BIM technologies. I believe it's going to be much more enhanced and work as a hub in the project, which you have seen some of the samples here. I believe the BIM processes are embedded into the whole construction process, and helping the team and understanding the importance of it. Because these technologies are fairly new, like maybe it picked up more in 10-15 years. Now we are seeing much more involvement and merging into the process. BIM is not a separate entity anymore in the construction phase, of course in the design phase as well, but BIM is kind of an embedded process into the whole construction process. I would say that is the trend that we are seeing is changing. I'm looking at other questions. There is one question I believe that we didn't answer. Has machine learning, artificial intelligence helped BIM, and how do you expect it will be in near and medium future? I believe this is where we are coming right now, with all this integration of tracking, data collection. I would say that the answer is the future BIM technologies and construction technologies is data collection. Data is there, it's just messy, and we are trying to organize this data so the project team can use, construction team can use, and then everybody can be having live updates from this. And we don't do that just for tracking. Actually, we have other studies that we develop in-house for the data collection, which BIM department is closely, monitoring and trying to implement those dashboards. But definitely, machine learning is one of the future, which hopefully, with the digital twin, we are going to achieve some AI in the construction, that we can use that data and take lesson learned, definitely.
Yeah, I would add maybe a little bit to that I personally haven't used any of the new tools coming that rely heavily on machine learning or AI. But what I think the future might hold is it would kind of reduce the amount of work that someone in my role would need to do, and it would allow us to do less of the kind of not tedious tasks, but more of just administrative terms in terms of data management, and let us spend more time making decisions and making sure things are progressing. So I think the tools are trying to do that, but better and better each year. I don't think they're quite ready yet, but I think that's the trend, that these tools, at least in terms of coordination and using BIM on a job, I think that's what they're trying to do, is give us more time to be productive instead of just kind of managing data.
Yep, I agree. Okay, I think we have time for another question. how is the BIM modeling passed on to the owner for facilities maintenance and facilities management? I believe, Bill, you mentioned it that you had periodical meetings with the facilities for the project.
Yes. So along with turning over as-built drawings in PDF format at project closeout, we typically take all of our coordination models and we package them up and turn over every model we've coordinated and drawn in the building. We will turn over NYU a package of basically their as-built models. So after coordination is done and after a floor is built, our subcontractors owe us as-built drawings, and we require them to update their 3D models to reflect as-built conditions, so that when the project is being closed out, we hand over to the owner not only 2D shop drawings of as-built conditions, we hand over NYU a package of 3D as-built models, so that they have almost a digital twin of their building that they can go and look at later if they ever need to either see what's behind a ceiling or a wall, or take a baseline of what was built to kind of jump off and do future designs or any modifications to the building. So we're turning over a full BIM package to NYU for this job.
Yep. Also, it really depends on the project to project. There are certain owners at the beginning of the project outlines these requirements, select the facilities management platform for a full BIM integration, or like Bill mentioned it can be just a model turnover, as-built model turnover for the facilities. There are several options that we provide to owner and present to owner that how they can use this information post-construction, during construction, that we produce this valuable data. Really depending on owner and the client request and needs. So we outline a plan and we follow that plan during construction to deliver a successful process for the post-construction that they can actually use. Some owners are more knowledgeable than the others overall, but we have, I believe, currently 5 projects going through facilities management, and other projects are under the discussion, maybe 3 or 4 projects under the discussion of how they can use and leverage this data. That's what I would say, actually. I believe we are completed all the questions.
Well,
we are good.
Ayse, I want to thank you and Sal and Bill basically for a fantastic presentation. I hope that all the participants got something out of them, and I'm sure they did. I know that I did. And it was very informative and very interesting of how BIM primarily is used, especially for a project of this magnitude. So again, thank you very much to the team and to Turner as well. Thank you. All right.
Thank you for
Have a
having
wonderful
us.
day, everybody.